Let's go to Lake 317. Shortest distance from all buildings. For this question, it gives us an integer array, two-dimensional integer array grid. And in this array, there are three types of value: 0, 1, and 2. 0 means empty land. You can pass by freely, and 1 means a building you cannot pass through, and 2 means obstacle you cannot pass through. You want to build a house on empty land that reaches all buildings in the shortest total traversal distance. So, you can go up, down, left, right, and return the shortest traversal distance for such a house. And we need to make sure that is we need to find those kind of zeros, right? That is empty land, and we need to have two conditions. One is that this land can reach all buildings. And the other is that it has a minimal total sum to all of the buildings, right? So we return this kind of minimal total sum. If we cannot find such a cell can reach all the buildings, it just return -1. So intuitively, what we can think about is that we iterate the grid and find if this is an empty land there, right? We do BFS, that is layer by layer, right? Now, like this, and trying to see if it reach a building. For this kind of starting point, we have a building counts +1. Building counts +1, and also the distance. The first layer is 1, right? Distance also plus the first one, right? And then it reaches to step by step to reach this building, right? This building +1, and distance will plus this will be the third layer, yeah, +3. And for every empty land, we will calculate two values. One is the building number, one is distance number, right? And after we finish every empty land doing BFS, we do a comparison for every empty land, trying to see whether the total building numbers equals the total ones in the grid, and then we update the distance, get the minimal value for that. For this kind of approach is that the time complexity will be the number of empty lands and multiplied by m, the n, right? So if the empty lands counts is a lot, maybe that this kind of approach will have some problem. It will close to m square, n square. But if the for this question, I think we need to clarify whether in the grid it is, for example, a lot of zeros, or it have a lot of ones. So if it has a lot of ones, almost every cell that is 1, there is only a few zeros. The count of empty land is not a big number. Doing like this will be a good approach. But for this question, we look at the example, looks 0 is more than 1. So we need to have some other approaches. Amogo, we do BFS from the land, but we can think about another way, that is we do BFS from the every buildings. And also do layer by layer, right? We create another grid called distances, and we add distances. For example, this is 1, right? To from this building, let's start from this building. We add this one to 1, 1, 1, and this is the first layer, and second layer will be 2, 2, 2, 2, right? This will be the distance to this building. And then here that will be 3, 3, 3, 3, right? So we can calculate, do BFS calculate every empty length to this kind of building's distance. And in the meanwhile, in the same way, we can do for this kind of building, right? That this one we need to add 1, and this one need to add 1, right? And this one, the second layer, we need to add 2. And this will be added 2, and this will be added 3, added 3. And also we do this, right? So in this case, every length, it will have a sum of the distance to all the reachable buildings. And also we create another array, which if there is a building can reach this cell, we just count how many buildings can be accessed to this cell. And after iterate all of the building to the BFS, the cumulative distance will be actually those kind of empty land to all of the buildings distance that sum, and the cumulative counts will be this cell can reach how many of the buildings. So doing like this way, if the building is sparse, the time complexity will be the count of buildings, right? And multiple by m and n. So doing like this approach probably looks better. So let's begin to write code. And we need to have distance array. Which will store for every empty land, store this kind of buildings distance adding to these kind of cells. And also we have buildings array, which will count to this kind of empty land, how many buildings can reach to. For int equals 0, and smaller than m plus plus. For int j equals 0, to smaller than n j plus plus. So I will say if grid I j is a building, right? Then we do BFS something, right? And also we can count the building numbers here. Building count. So after we do the BFS, we are get this distance array. The different for this distances, the sum of the distance from the empty land to all the buildings, and also the buildings array for the empty land, how many buildings it reaches. So we can also do this in shortest integer dot max value. So for int I equals 0, smaller than n plus plus dot int j equals 0, j is smaller than a plus plus. If grid I j equals one, right? Doesn't need to be empty, empty land. And buildings I J equals building parts. A shortest distance of mean shortest distances I J, right? And we return shortest. The problem is that for this kind of grid, it's possible there is no empty land, or for some kind of empty land, it cannot reach all of the buildings, or it should be 0. Sorry, cannot reach all of the buildings. So in that case, the shortest will remain integer maximum. So if this integer maximum, that means we cannot find such a empty land. So we'll return shortest plus max value. Or if this max value return maximum, otherwise we return shortest. And then we write a BFS functions private y BFS. We need to pass in the grid, and we need to have row, right? And we have the column, and we need to have what we need to get the distance. Distance is array. And also we need to have the building count array buildings. Int and grid. Let's put grid. So let's we know for two-dimensional array, right? The coordinator we convert to integer. That is index equals 0 multiplied by n column, right? Column index. And when we want to get a row, will be index divided by n. And we want to get the column index, that will be index multiplied by n. So we can use a q integer to plus new array effect for BFS. And we can also use a set for validity. Actually, we can use this visited. It's a new volume. And so we need to have to offer I multiplied by n of j, and the value I j true. So BFS, that is y q is not empty. We need to have a distance or steps, right? We call distance. It's let's have this one started with 1. Int size equals q dot size 4 until I equals 0 and smaller than size plus plus. And for every layer, we have this plus plus. So current index equals q dot per point out, and we need our row equals dx divided by n, and the column is small by n. Then we want to get the 4 directions. We need to have a direction array. D0 equals 1, 0, minus 1, 0. Until the column equals 0, 1, 0, minus 1. 4. Into k equals 0, k is smaller than 4, k plus plus. So we have int new row equals 0 plus d0 k, and int new column equals column plus d column k. And we want to see, make sure it is it is in bound, right? So if new row smaller than 0, or new row greater equal to m, or new column smaller than 0, or new column greater equal to n, we are going to continue. And also, if this is this kind of cell is not empty land, we also need to continue, right? Because we cannot reach it. So we have grid new row, new column. If it doesn't equal to 0, right? We also need to continue. And also, if related, new row, new column, we also need to continue. And we now need to use the cube offer new row multiplied by n, that's new column, in the related new row, new column equals 2. And we want to have a distance with new row, new column, plus equals this. And we want to have buildings, new row, new column, plus. Great. Buildings. let's have GKR. Intuition. Um, for this kind of approach, the time complexity will be the number of the buildings multiplied by m and n. Space complexity will be m multiplied by n.